How does coordinate geometry relate to trigonometry? Have you ever wondered how coordinate geometry and trigonometry work together? These two areas of mathematics are closely linked, and understanding their connection can make learning both much easier. Let's break it down step by step. First, let's talk about the unit circle. This is a circle centered at the origin, which is the point where the x-axis and y-axis meet, with a radius of 1. Trigonometric functions like sine and cosine are based on this circle. For any angle measured from the positive x-axis, the coordinates of a point on the unit circle are given by the cosine of that angle for the x-coordinate and the sine of that angle for the y-coordinate. This means that angles can be represented as points on a plane, which helps visualize trigonometric ratios in a clear way. Next, consider right triangles on the coordinate plane. When you plot a point with coordinates, you can create a right triangle by drawing a line straight down to the x-axis. The lengths of the triangle's legs correspond to the absolute values of the x and y coordinates. The hypotenuse is the distance from the origin to the point, which can be calculated using the distance formula. This relationship allows us to express trigonometric ratios like sine, cosine, and tangent as ratios of these coordinates, making it easier to work with angles, even those greater than 90 degrees. Another important connection is the Pythagorean identity. This identity states that the square of the sine of an angle plus the square of the cosine of that angle equals 1. This matches the equation of the unit circle, showing how trigonometric functions relate to geometry. Angles and slopes also play a role in this relationship. In coordinate geometry, you can measure the angle between lines using slopes. The tangent of an angle can be found as the ratio of the sine to cosine, which corresponds to the slope of a line segment from the origin to the point on the coordinate plane. This means that trigonometry helps us understand slopes and angles, making it easier to analyze shapes like triangles and polygons. Finally, combining coordinate geometry and trigonometry allows us to solve various problems involving distances, angles, and areas of shapes. For example, you can find unknown side lengths or angles in triangles plotted on the coordinate plane. You can also analyze polygons by breaking them down into triangles and understand circular arcs through angles measured on the unit circle. In essence, coordinate geometry gives us a visual and algebraic framework for trigonometry. Angles correspond to points on the plane, and trigonometric ratios emerge naturally from the coordinates of these points. This relationship simplifies our understanding of shapes, angles, and triangles by linking spatial concepts to numerical values on the Cartesian plane.